Assalamualaikum warahmatullahi wabarakatuh and selamat sejahtera. My name is Dr. Nur Shafiza Shahabuddin. You can call me Dr. Shafiza. I will be teaching you this chapter, periodic table. So these are our subtopics: definition, arrangement, relationship of the first 20 elements, and also trend in physical and chemical properties. For the first part of our lecture, our learning objective is number one is to discuss the basics for the arrangement of elements in the periodic table. How is actually periodic table is arranged? How are the elements arranged in the periodic tables? Number two is you should be able to give the locations in the periodic table of the representative or main group elements, transition elements, and also inner transition elements. And number three, you should be able to write the electronic configuration of any element from the position of the element in the periodic table. What is the periodic table? Okay, it is actually a table that contains all known elements in the universe. So this table actually organizes the elements by chemical properties. So who created it or who found it? So in 1860, about 60 elements were known and a method was needed for organization. The quest for a systematic arrangement of the elements started with the discovery of individual elements. So in 1869, Russian chemist Dmitry Mendeleev proposed arranging elements according to their atomic mass or atomic weight, and also according to their chemical properties. The table, however, contained gaps, but Mendeleev predicted the discovery of new elements. So Mendeleev's periodic table allowed for the prediction of elements not yet discovered based on their physical and chemical properties. For example, here Mendeleev already predicted gallium and also germanium, and finally it is the element was actually founded later containing the properties as predicted as Mendeleev before. So elements in the periodic table are also grouped into families, which are the columns. So elements in families have similar properties. All the elements in a specific column have similar properties. The elements found are also categorized into periods or horizontal rows. Elements in periods do not have similar properties, unlike the elements in column. This is a periodic table you are already familiar with. As you know, you have metals, you have metalloids, and also you have non-metals. You also have the transition elements in the periodic table. So what is new for our topic? In this topic, the periodic table is divided into several blocks which have some similarities. There is S block, colored in blue, consists of groups 1 and 2. There is P block, colored in pink, consists of group 13 up to group 18. And there is D block elements, colored in yellow, and the green colored elements are the elements of F block. So what are actually these blocks and what are their characteristics? Let's look at the characteristics of columns first. Columns of elements are called groups or families. Elements in each family have similar chemical and physical properties. For example, lithium, sodium, and potassium and other members of group 1 are all soft, white, and shiny metals. All elements in a group have the same number of valence electrons. For example, for group 1, they have S1 as their valence electron. Characteristic of periods. Each horizontal row of elements is called a period. The elements in a period are not alike in properties. In fact, the properties change greatly across even a given row. For example, the first element in a period is always an extremely active solid, whereas the last element in a period is always an inactive gas. How elements are arranged in the modern periodic table. The elements are arranged from left to right in increasing proton number. The elements are arranged in 7 horizontal rows, which is known as period. The elements are also arranged in 18 numbered vertical columns, which is known as groups. Each element in a group has the similar valence electrons and also similar chemical properties. Okay, for S block, which contains group 1 and group 2, their similarity is that the elements in the S block has outer shell electrons in the S subshell. So you know from the valence electron is Ns1 and Ns2. Okay, and for P block, which contain groups 13 to groups 18, their outer shell electrons are in the p subshell or p orbital. So it would be Ns2 and Np1 to Ns2 and P6. And for D block elements, it contains transition metals from group 3 to group 12. So here D electrons first appear in the fourth period. So the D subshell is finally being filled. So for example, here we have ND1 and S2 up to ND10 and S2. For example, scandium with the proton number 21, you have the configuration electron of argon for S2 3D1. And finally, for the F block, you have lanthanides and actinides. So F electrons first appear in the sixth group, where the F subshell or F orbital is being progressively filled. For example, cerium 58, we have xenon N62 for F1 and 5D1. So finally, you can see that F orbital is being filled with electron.